My name is Jonathan Quinn, and this is Cherry. And within this session, we're going to be talking about high availability and disaster recovery. So the two risks that we want to focus on within this presentation are data loss and downtime. And these can adversely affect your business operations. They can affect customer trust. They can cost your organization valuable time and money. So an organization may say, well, we can't tolerate a day's worth of downtime, or they can't tolerate a day's worth of data loss. So in this presentation, we want to go through some of the different ways that ArcGIS Enterprise can offer ways to minimize the risk of data loss and downtime. And there's three different approaches that we're going to be focusing on. The first is backups. So backups, you may all be familiar with it. It's simply taking a snapshot of an environment at a point in time. You're storing that backup in a secure location, and in the event of a disaster, you're able to restore the backup to continue to return to a functioning state. The next approach is high availability. High availability means you don't have a single point of failure. So you have multiple machines performing the same function. If one of those machines goes down, then you have other machines to continue to perform the same role. This largely revolves around machine redundancy. Another approach is disaster recovery using geographic redundancy. Using this approach, you have multiple data centers that are mirrored, and they're configured identically, and you're replicating data between the data centers. In the event you have a data center level failure, you can flip over to your standby data center to continue normal operations. So the three approaches that I just discussed, they're not exclusive of each other. You don't go for backups over HA or HA over backups. They're complementary of each other, and they build on each other to develop your disaster recovery plan. So an organization that is developing geographic redundancy in between multiple data centers are likely also going to be highly available within a data center itself. So the cost to achieve high availability or disaster recovery, that's largely going to direct an organization towards one approach or another. Understanding the resources required to set up as many machines as you need to be HA, to be highly available. Having the staff to be able to implement a highly available storage or a load balancer, or even the time it takes to actually practice your disaster recovery plan, make sure failover is working correctly. All these different costs are involved in your disaster recovery plan. So first thing I want to cover is backup and restore. So this is simply taking a backup of an environment to be able to restore it. You can say this is somewhat the easiest way to minimize data loss and downtime. Often it can be performed hot, meaning there's no downtime on the system. Users can still access the resources they need and continue to use the resources that are available to them. These backups can run in the background to make sure that you're creating snapshots of the environment and the data. And they're often, sometimes they're underappreciated. On my phone, I'm saving the backups of my contacts, and I don't really have to think about it. And I know that, if I have to get a new phone, I can simply restore those. So it is kind of an underappreciated way to really, preserve data and to minimize data loss. There are a number of different ways that you can create these snapshots. VM backups, so you can snapshot a VM or a virtual machine. You can back up file systems, so file server backups. And you can get to software level backups. This is SQL Server or an enterprise database having a backup utilities. Or in our case, ArcGIS Enterprise. So the ArcGIS Enterprise can be backed up in a few different ways, whether it's on the file system. For this session, we're going to be talking about the WebGIS Disaster Recovery tool, which can be used to back up your full enterprise. To start, I want to cover a bit of background about the disaster recovery tool. First, what it does. So the disaster recovery tool will back up all the settings within portal, server, or any federated server, including the hosting server, as well as the ArcGIS DataStore. It backs up the portal content. and the internal database that stores users, groups, and item information. It'll back up all the services within your federated server and the hosting server. And it'll also back up the ArcGIS DataStore, including the scene tile cache, or optionally the scene tile cache DataStore. And the time to take to create the backups is largely going to be dependent on the size of your enterprise, how much content you have within the portal, how many services you have, how much data is copied to the server or to the data store when you're publishing. All these factors come into play when you're trying to figure out how big these backups are going to be. So this does require Portal for ArcGIS at minimum. It's available within the tools directory of Portal. And we're going to go ahead and talk about the usage in a couple of slides. So while we can talk about what the tool backs up, it's also important to talk about what the tool doesn't back up. So what your organization is going to be required for backing up. And this is any enterprise geodatabase data. So you can have your SQL Server database, your Oracle or Postgres enterprise geodatabases, or any file-based data used within services. It's up to you and your organization to make sure that that data is backed up using the backup utilities available for those databases or file server backups. The other thing that's not included within the DR tool backup are the traditional cache tiles. So the tiles served with cache services. And as you know, these can grow to gigabytes, terabytes even. So it's really not feasible to include those within the DR tool backup. It's probably a better approach to rely on file server backups to back up any of these traditional cache tiles. So in general, what are the properties that, or how do you go about using the disaster recovery tool to back up your environment? Well, first you have the DR tool. This resides within the tools directory of Portal. You have the properties file, where you define the properties used to back up the environment. The URL that you want the DR tool to use to connect to a portal, where to stage each of the individual backups, or where to zip up the entire backup after each individual backup is completed. Credentials, obviously, to connect to the portal as an administrator, and whether or not to include the scene tile cache data store, or scene tile caches. Once you've defined all these properties, you can kind of confirm that it does run effectively, you can restore it. You're going to want to automate it. You want to make sure that you don't run it once, you kind of run it at a continual basis, so you always get a backup of your entire enterprise at a point in time. So once you begin populating the DR tool properties file, there are a couple questions that you have to ask yourself. One is, where is my content located? And this is important because when the content's on the file system, we can include that within the DR tool backup itself. So we actually zip it up within the backup. But when your content is in cloud storage, we want to make sure that we retain it in cloud storage. We keep it in cloud storage. So in that case, you can provide a backup container name or a backup bucket name. The next question you have to ask yourself is, where do you want your backup stored? There's a couple different approaches. You can store it on the file system. Obviously, it should reside in a secure location so that in the event that your machines go down, you can still restore it. You can also store it in cloud storage as well. Cloud storage obviously offers highly available storage so that it's always accessible in the event of a disaster. So we support buckets and containers. Now, there are minimum parameters that are required to run the tool. And I just want to highlight those here. So the shared location is where each backup will be staged before the DR tool zips them up to create the DR tool backup. So portal and server and data store will be staged in this shared location first, and then before the DR tool zips it up. The backup store provider is where you want to store the backup, whether that's on the file system or in cloud storage. The portal admin URL is the URL used to connect to the portal that you want to back up. At 10.7, this supports IWA, any Windows authentication, such as PKI or LDAP, or again, IWA. Prior to 10.7, you had to put in the port or a URL that bypasses any of the Windows authentication. The portal admin username and password have to be an administrator within the portal site, whether that's an administrator through Active Directory or a built-in administrator. Either one works. And next you define whether you want to run a full backup or an incremental backup. And we're going to go into a little bit more information about the difference between full and backup when we get to disaster recovery using geographic redundancy. So I want to cover the usage of the tool. When you're running a backup, the backups run concurrently, meaning as soon as the DR tool starts, it'll start the backup for portal, server, and DataStore at the same time. There's no downtime while exporting, and the syntax you'd use is you provide the path to the DR tool batch file or the shell script on Linux. You use the -E or -export switch to indicate that you want to export, and -F or --F to point to the properties file that you've populated with the information about the backup mode and URL and that sort of thing. When you're ready to restore, the restore runs sequentially. So first it'll restore DataStore, then it will restore all the federated servers, and then it will restore portal. It's important to note that there is downtime while you're restoring, so your environment, your enterprise, is not going to be available while the restore is completing. The syntax is very similar. Instead of -E or -export, use -I or -import to restore a backup. So as I said before, your ideal situation is that you're automating your backup. And in one case, you can use, if you're on Windows, you can use the task scheduler. Just want to highlight real quickly the process to go through to schedule these backups. First thing you'll do is you create a basic task. You define when that task should be run. It's important to note that when you're running the backups, you're going to be using CPU on the system. If all the components are on the same machine, then you've got portal, server, and DataStore all running the same backup. So you really shouldn't be running backups during normal operating hours. Ideally, you'd be running it at midnight or non-peak hours. Then when you're defining the program to run, you provide the path to the batch file, and then you provide the arguments as if you were to run it normally, or manually. -E to export, -F to provide the path to the properties file. And then you hit finish, and then you've got a defined schedule to back up your deployment every day. On Linux, you'll use a cron tab, so you define the schedule based on the schedule that you find within the cron tab. For example, you could run it at midnight every day, or every 12 hours, and that's going to be really dependent on your time schedule for how much data loss or how much downtime you can really withstand. All right, and with that, we'll switch over to talk about high availability.
Thank you, John. You just heard John talk about backup and restore. For some organizations, that's not good enough, though. You know that few hours downtime to restore is not going to work. For those organizations, we move to the next level, the high availability. In this part of the presentation, we'll first take a step back to take a look, what is high availability? And then we'll talk about the high availability for ArcGIS Enterprise, all the components and how to upgrade high availability deployment. And in the end, we have some key points that we would like you to keep in mind when you deploy high availability. First, what is high availability? Basically, high availability is a system, right? It's continue working for the length of time of your desire. The length of the time can be measured by SLAs, which is term is most of us are more familiar with. Basically, it's how many nines. Is your system 99.9% and 99.99%? And when you get more nines, it costs more. Every 9 you add, it gets more and more costly. The key for high availability is to eliminate single point of failure. So your deployment won't go down because of the failure of one single component. And of course, the availability of your system depends on the availability of all the components. not just ArcGIS Enterprise. We are just part of it. And in that session, I'll talk a little bit about it more. But in this session, we mainly go deeper dive on the ArcGIS Enterprise high availability features. First, we take a look at what's ArcGIS Enterprise. When we talk about high availability, what are the components we are going to talk about? You probably already know, it's a portal, server, DataStore. It also has a web adapter, which web adapter is tied to portal and server. So we'll talk about web adapter as well when we cover the portal and the server. First, let's take a look at the portal. Now, this is a high available deployment of portal, high available portal. It has two portal machines, and it needs load balancing in front of it. The portal content needs to be shared between the two portal machines. The two portal machines, they both take requests. Look like they are active since they both take requests. Actually, internally, there is a difference between these two machines. That's a screenshot from the portal admin. If you have a high available portal, you will see that actually there's a difference of the two. One is called primary, one is called standby. The difference of these two is how portal behave differently depends on which machine is down. If the standby machine is down, your portal, there's no interruption, just continue to work. Your end user won't notice anything. But if it's the primary machine is down, your end user will notice like internet freeze a little bit, things get slow a little bit, and then it recovers. That's how it feels. This time is about after 10:06 one, and later it's 30 seconds. Before that is a few minutes. So we made an improvement right there. So this is the difference of these two machines. And some of you probably know actually internally that's because of there is a failover happen. Depends on the primary or standby, which machine is down. We set the portal, high available portal need a load balancing in front of it. For the load balancing option, there are two options. First, use ArcGIS web adapter, which is from Esri. It supports web tier authentication, but the availability of the web adapter depends on the web server, right? Because it deploys to the web server. So you want to make sure that a web server, web adapter is also high available. And then another option is to use a load balancer. It's usually not provided by Esri. Not usually, it is not provided by Esri. It's typically already have the fault tolerance feature. A lot of those, especially those commercial ones, usually have pretty good high availability features already. So when we put it together, for the deployment patterns, when you deploy a high available portal, on the first one, because you don't have the tier for web adapter, so it's simpler. It needs some certain settings on the load balancer, but usually it's pretty simple and straightforward to set. But it doesn't support web tier authentication because it doesn't have the web adapter. And on the right side, it's more complex because it has a tier of the web adapter here, so it supports web tier authentication. But you want to make sure that your web adapters also highly available, not single web adapter, so no single point of failure there. Some load balancers support a health check function. It depends if the machine's healthy to take request. And the portal provides an out-of-box health check endpoint to determine if the portal is ready to take a request. This URL we listed, that's the health check URL. But this health check URL, though, it tells you if portal is healthy, the whole portal is ready to take a request. It doesn't really tell you if certain item or certain service is healthy enough. If you need that level, that fine-tuned health check, you can create your own customized health check. Next, we take a look at upgrade. Right? You probably think, great, there are two machines. I can take one machine down, upgrade, and then put it back, upgrade the other one, so there's no downtime. Unfortunately, it doesn't work that way. There is downtime. Because you can see they share the portal content. When you upgrade, they also upgrade the portal content as well. So the other machine won't work at the same time, at the meantime. So there is downtime when you upgrade high available portal. Even though there are two machines, it's still one portal. So you probably want to plan well. You want to practice, and it's always a good idea to make a backup. let's take a look at the procedure how to upgrade. If you upgrade a portal even on a single machine before, you know actually there are two general steps. One is to use setup to lay down the software bits, the new version of the software bits. One is, we call it configure. That's the step really upgrade to the new version. On portal, high available portal, similarly, you need to lay down the software, run the setup first on both machines before you run the configure. And then, before 10.6.1 before, you must run the configure on the primary machine. But at the 10.7, it doesn't matter anymore. You just need to run once on any machine. It will bring both machines and all your settings go to the new version. There are some other steps, for example, like do reindex or leaving atlas upgrade, depends on which version you are. Those steps is the same high available portal or single machine portal. You just need to follow our documentation on that. So quickly, some key considerations for portal. There are two machines, one primary, one standby. Portal behave differently, depends which machine is done. And it requires a high available load balancer. Depends if you want web tier authentication or not. Depends if you want a web adapter. And then when you need a web adapter, make sure you don't have a single web adapter. There's health check provided by portal for ArcGIS, and you require a high available shared content store. And during upgrade, there's downtime. And there's certain steps in order. That orders got loosened up more and more with later release, but there's still some orders when you upgrade. Next, let's take a look at ArcGIS Server. Different from portal, right? ArcGIS Server is a multi-machine high available deployment. It's not just two machines. And all these machines, they are identical. They are the same from one to the other. There's no difference between them. And then any single machine is done, any one machine is done, as long as you still have one machine up and running, there's no interruption. Well, as you have less machine, might be getting performance hit, but from the running point of view, there's no interruption. And the config store and the server directories, similar to the portal content store, it needs to be accessible, need to be shared to all machines. And similarly, there are also two patterns, right? On the left side, just a load balancer is easier, but no web tier authentication. And on the right side is more complex, but it supports web tier authentication. Just make sure that you don't have single web adapter. Similarly, server has a health check out-of-box endpoint as well. It, again, is only check if server is ready, is healthy. It doesn't check your any single services out of the box. You can create your own if you need a level of health check. On upgrade, for servers upgrade, it also have two steps, install and configure, install and upgrade. This need to be run on every single machine. Every machine you run this. In the future, there might be changes, but currently you need to do that on every single machine. And the downtime though, because when you upgrade, you bring the config store up to the new version as well. The downtime is the same as when you upgrade one machine. As soon as one machine is upgraded, you're set up and running again. So there's still downtime, but it's similar to when you upgrade one machine side. You probably already know that the portal and the server need to federate for them to work together. In here, we want to talk about a few important URLs you want to pay attention. You probably won't hear this in other administration sessions because we usually take care of it when it's a single machine deployment. But when you come into HA, high availability deployment, we notice people get tripped over by this pretty often because it's just not really up to your face. It's during the deployment. In the portal has a public URL. We call it a portal URL run on 443. That's previous diagram. You notice that people realize that it is pretty obvious. A server has a service URL running on 443. Portal also have a private URL running on 7443 doing administrative tasks. The server similarly running on 6443. During the federation, there's communication between the public URLs. There's also communication between the administrative, there's administrative communication between the private URLs. when you federate, it's pretty obvious that the portal asking you the public URL and asking you the private URL. On the server side, if you go to the server admin, after federation, you see actually server remember 2 URL from portal as well, the public URL and the private URL. For a single machine, it's just the machine name with a port number for the private URL. That's why we say we usually take care of that for you already. Portal and server just compute that for you. But for high availability, you need to make sure all these 4 URLs also highly available. Do not use the machine name. This portal URL and the server public URL, people get that, high available, you need a load balancer in front. But for the private URL, you want to use the load balancer as well. Or you can, have another load balancer, or you open another port in your load balancer. Just make sure they are highly available. Do not use any machine name, machine 1, machine 2's name. Because when that machine down, the administrative communication will be done. You see weird things that's not quite obvious what's going on. Just make sure this URL needs to be highly available as well. So that's a quick summary for the server high availability considerations. You need a high available shared config store and server directories. There's health track provided for ArcGIS Server. And these 4 URLs for communication with the portal, make sure they are all highly available. And then you need to install and upgrade on every single machine. And there is downtime during upgrade. Next, we'll take a look at DataStore. We have different type of data stores: relational data store, tile cache, and a spatiotemporal data store. In this session, when I talk about high availability, I'm really talking about the relational data store and the tile cache. Spatiotemporal is a pretty heavy component by itself. It's used for certain analytics tasks. If you are interested in that one is a whole set by itself of high availability backup. There is a session, but unfortunately it's already passed. You can go back to watch video or just come to the island. Bring your questions or you want to know more about it. Come to the expo. We can have the expert talk to you about that. Okay, now we take a look at the high availability feature for the data store. The data store high availability settings still 2 machines. Big difference, one called primary, one called standby. The primary write backups to the backup location. And the primary constantly streaming to the standby. Standby is constantly replicated from the primary. And only the primary machine take a request. When the primary machine is done, all the connections done, the standby will promote itself to become the primary machine to take the request. We call this a failover scenario. Well, in this deployment, you can see the key point is when this failover is going to happen, what trigger that we consider the primary machine doesn't work anymore. This is a very, very tricky thing. We have pretty good documentation on this. What people don't realize, is the data store is a database, right? This database failover usually is pretty costly, pretty expensive. We want to make sure that really it's a crash. It's not scheduled. It's not because you gracefully shut down your machine or shut down data store because you want to apply a security patch. It's planned. You know it's going to happen. You bring them back. It's not an unexpected case. We only fail over what we consider as unexpected scenario. You check our documentation and you can ping us as well if you don't quite understand. This is a key. We have user ask us, I shut down primary data store. How come it didn't fail over? Because we don't consider that's a disaster. We consider that's a planned scenario. For upgrade, very similar to Portal, you need to lay down the software base first on both machines. And then before 10.6.1 and before, you run upgrade. You have to run upgrade on the primary machine. But from 10.7, doesn't matter which machine you run it. It will bring the both machine up to the version and relational and the tile cache. Now we put them together. This is ArcGIS Enterprise high availability deployment. every single component need to be highly available. And then there's orders from upgrade as well. You probably already know, we need to upgrade portal first, and then server, and then DataStore. This is not just a high availability portal, ArcGIS Enterprise. Even when you're on a single machine, this is a requirement from the ArcGIS Enterprise, not highly available portal. But so we're following the same requirement, the same order. These slides have a lot of information, actually, a lot of interesting information. You see some of the component I talked about earlier, right? Like the shared config store, shared content store. It needs to be highly available. When you deploy on the cloud, there are some really nice cloud features that you can take advantage of. For example, the portal content store. Right? We support Cloud Store as a portal content store, and also some cloud features for ArcGIS Server config store. These cloud storage, they are highly available. They are managed by the cloud provider. You don't have to worry about that part. And also for some features, like for the cloud storage that you can register to Server Manager, it can use for caching, for geoanalytics, big data input, similarly for raster analytics. These are also very nice, not just because they are highly available, also because they are highly scalable. You can almost consider they have limited space. When you have huge data, you may not have that big storage on premise, but in the cloud, take advantage of these cloud features. For the caching part, we can share with you, with data performance, right? Testing these storage compared to a physical storage to your machine. Of course, it's not as good as a physical storage attached to your machine directly, but the performance is very similar to ArcGIS Online. If you're okay when you go to ArcGIS Online, you see those zoom in and out, that okay with that performance, this feature might be good for you. What I circled here is like we supported Amazon S3 and Azure Blob Storage, and we added also support cloud storage from Alibaba Cloud and Huawei Cloud. Okay, now we come to some key points that we like to communicate with you. I mentioned, ArcGIS Enterprise HA. It's just part of your HA architecture. There are a lot of other important features, like your data, right? Your data is it enterprise geodatabase? Is it file-based data? Are they highly available? The enterprise geodatabase, usually the database have very nice, highly available features. You need to configure that as well. And the software, is your web server, if you use web adapter, is it highly available? Your load balancer highly available? Hardware, right, the file share, the very important file share for content store, for config store. And the network, is your network also highly available? And very important thing people don't realize sometimes is the people, is your staff highly available? When your high available staff on vacation, you have someone IT strong enough to cover him. When you have two staff, you probably don't want them to go on vacation at the same time. So your people need to be highly available as well. For highly available deployment, the IT governance is very important. You want to ensure the effective and efficient use of your IT. You just really want to plan it well. You want to be very highly disciplined. You want to update your document in timely manner, very clearly. Most importantly, you want to test. You want to exercise. Just like fire drill, why do we do fire drill? Same thing, we want to do the exercise here. You want to make sure when a disaster happens, your system really works, can really be highly available. Again, we want to emphasize that high availability is a spectrum. It's not a switch. It's not that is your system highly available or not. It's where your system is at for availability. As your system's requirement goes higher and higher, which means less and less downtime, it's more and more costly. By nature, high availability is not a simple thing. Basically, you need to double your hardware. You need to double your staff. Just it's not a simple thing to deploy high availability. You want to really plan carefully where your system needs to be, for availability. For example, if you are 911, you definitely want to be highly available, right? You are down, people die. But if you are just a GIS shop that you have 4 or 5 staff that only them access your deployment, do you really need to come in the middle of the night to fix it if your deployment is down? Is the next day's couple of hours recover to the day before, or maybe even a week before? Is that good enough for you? You really want to plan carefully and find that spot on the availability spectrum that is right for you. With that, we're moving to the disaster recovery. Back to John again.
Thank you. Yep, so here we're going to talk about disaster recovery using geographic redundancy for your disaster recovery plan. First, we're going to talk about what is geographic redundancy. We'll talk about how to achieve it using the WebGIS DR tool. And we're going to cover the roadmap to becoming geographically redundant. So as an overview, geographic redundancy means that you have geographically separate data centers. And the data centers, you likely have a primary, let's say on the East Coast. You have a standby, the Midwest or West Coast. And if the primary goes down for some catastrophic reason, natural disaster, you can fail over to your standby data center. So as I mentioned before, within a data center, you're likely going to be highly available as well. So if your organization is going to invest in geographic redundancy, setting up multiple data centers, within those data centers, they're likely going to have resources available to set up HA as well. So the DR tool can be used to move snapshots of data and configurations from primary to standby. And this is a pretty complex disaster recovery option. It requires duplicating the configurations, the data between 2 separate environments. Configuring a schedule that matches the amount of data you have and understanding how long it takes to restore. So this is one of the more complex disaster recovery options for your enterprise. So I want to cover just a theoretical workflow of geographic redundancy. Let's say you have an environment fronted by a traffic manager or load balancer. The public URL is mysite.esri.com/portal. The services URL is mysite.esri.com/server. And the traffic manager is sending all the traffic to your primary data center, whether it's on the East Coast or wherever it is. One of the requirements for the tool is that where you take a backup, the URL that users use to reach the resources in the portal, it has to be the same as the URL of the environment that you're restoring to. So these 2 environments are configured with the same public URL, but anywhere that you access the public URL, you're being routed to primary. So using the disaster recovery tool, taking backups of your East Coast data center, and then, I just messed up the surprise. So then you're storing it to your West Coast data center. And then, in the event that your primary goes down, you can flip over your traffic manager to point to standby to continue normal operations. You have this scheduled task of kind of restoring backups from primary to standby. So you've got minimum downtime and data loss because you're keeping the standby in this kind of warm state. For cloud deployments, as I mentioned before, and kind of the questions you have to ask yourself of populating the properties file. In this approach with cloud deployments, you've got an environment within, let's say, the East Coast region, US East 1 or wherever, and you can back up your content to a different region, like a central region, US Central 1 or any other region, and then you can restore it to an environment within a 3rd region. So I assume you guys are all familiar with what happened with Amazon, when a whole region went down, right? I mean, you can avoid those types of problems with, being able to distribute your environments and your backups across separate regions. So what's the roadmap for becoming geographically redundant? What do you have to do to get there? There's 4 main steps, and I'm going to go through each, in more detail through each step. But the first step is to duplicate the environment between primary and standby. This means, setting up the environment in standby, federating, registering the DataStore, registering any additional federated servers with their respective server roles. The next approach is to start creating snapshots of your primary data center. And then third is applying them to your standby. This should obviously be some sort of automated process through Windows Task Scheduler, or if you're on Linux, a cron job. And finally, monitoring is really important. And this is actually really across both data centers. Both environments, you should really have some monitoring in place. And this is monitoring, each individual component, monitoring, the health of your standby environment. So we're going to go into a little bit more detail about that process. So the first step is duplication. For duplication, again, you're making your standby environment the same as primary. And obviously our recommendation is that, well, if you have a fully HA environment in primary, you should really have one in standby. If you do have to fail over to standby, you don't want to drop in redundancy, you don't want to drop in performance, but many organizations, or some organizations, may not want to invest in the same amount of resources between primary and standby. Maybe all the users are on the East Coast, and that's where their primary data center is. So that's where they're going to invest in HA and that sort of thing. So the DR tool can restore an HA environment to a non-HA environment, or any really combination of the two. As I mentioned before, identical URLs are required for the DR tool. So the public URL and the services URL that you use to federate has to be identical. And this is because in the event that you have to fail over to standby, you don't want your users to have to think about what URL they should be using to reach their maps and their applications and their services. That should really be seamless for the user. And you don't want to have them to think about, oh, am I in standby or primary? Which URL do I use? Another thing that's important to keep in mind is that there are dependencies with services to paths to data. This is with connection strings, or with shares to file-based data, or any shapefile data. And that path has to be identical between your primary and standby environment. There are a couple ways to achieve that. Either you can use aliases within the Esri host file. Let's say you have SQL Server instance 1 in primary. That connection string standby, when you restore the services, it's going to try to use SQL Server 1 connection string, which may not be available. So one approach, if you have to, if you can't have, if these are all within the same network, you can use the Esri host file to kind of mimic it, to think it's the same name. But it's important to keep in mind that connection string has to be the same. In terms of file-based data, you can use symbolic links, either the make link command within Windows, or simply mounting the share onto the Linux machine. But the physical path that it uses to access the services should be the same, or really has to be the same, between your two different environments. And this is obviously a complicated step. Setting up the correct number of machines you have, making sure that federation is all set, the number of roles, or the server roles are mimicked between primary and standby. And obviously this can be helped with using Chef or some sort of automation scripts to set up the environment. So I want to cover what needs to be the same. This is some feedback that we got about, that. Well, I guess I'll start by saying when the DR tool was released to 10.4, one of the requirements that everything had to be the same. This is because it was the first release of the tool. We wanted to make sure that there was some baseline to how well it performs. And this means that everything had to be the same. This was the public-facing URLs, which really doesn't change throughout releases, as I mentioned before, but by reference data stores had to be the same. Server-side directory paths, machine names, and security information like proxy information. And obviously some of the bigger feedback that we got was, well, I'm not going to be able to mimic the same machine names between environments, which also corresponds to some of the internal URLs that Cherry mentioned, the private portal URL, the admin URLs to federate. Between different data centers, it's not feasible for an organization, for us to ask an organization to make those the same. So moving ahead to 10.5 and onto 10.6, we removed the requirement that machine names had to be the same. So you can restore environment with different machine names in your primary, and they could have different machine names in standby. So then moving ahead after that to 10.6.1 and 10.7, we started to remove some of the other requirements, like security information. Anything tied to a specific host name that is specific to a data center, we want to kind of get rid of that, and as a requirement that has to be mimicked across the data center. In your primary environment, you could have a proxy server. That proxy server doesn't exist in standby, but when we take a backup and restore it, let's say in everything prior to 10.6 or 10.6.1 really, that proxy information was also applied to your standby. If that proxy server didn't exist, then your environment is going to be broken. So moving ahead to 10.6.1 and 10.7, we wanted to make sure that, again, anything kind of site-specific that isn't easily mimicked within your standby environment, that requirement is removed. This is proxy information for portal and server site directory paths. So, where the config store path lives, or the directories path for server. That can be different between your primary and standby environment. All right, so moving ahead to step 2, creating snapshots. There's 2 different types of snapshots that you can create. And I'll start with a full snapshot. So the full snapshot is much like just what a backup is doing. It's getting the initial snapshot of all the data within portal, server, and DataStore at a specific point in time. Internally, it's defining a base backup timestamp that's going to be used for the incremental snapshot. Now, the incremental snapshot was added at 10.5 to reduce the time it takes to synchronize data between your 2 different data centers. And it captures the data that has been updated or modified after the last full backup. So the best way to describe this is obviously through images. So let's say that on Sunday you take a full backup. Monday you've got an incremental backup. Tuesday, every day you create a new incremental backup, and it's always capturing all the information, all the data that has been changed across every single component since the last full backup. But as you can see, as time goes on, at some point it's going to be counterproductive and counterintuitive to continue to create incremental backups. So your backup schedule should be defined correctly so that every so often you are taking a full backup to reset the size of your incremental backup. So then once you're ready to apply snapshots, there's 2 different approaches that you can take. And applying snapshots, I simply mean restoring the backups. You can restore them as they're ready on a scheduled task, or at the time of failure. And obviously we're going to suggest, well, you need to make sure that your standby is in a warm state, right? So you don't have to wait, in the event of a failure, you don't have to wait for you to restore a backup before you can flip over. So once those backups those snapshots are ready, they should be immediately restored to your standby, so that at any point in time, as long as your standby is not, you don't have a restore currently ongoing in the environment, you can flip over to let your users continue to use the enterprise. So last step is monitoring, and this is a really important piece I want to stress, that monitoring is crucial to any environment, whether it's standalone or HA or using geographic redundancy. As you start moving these snapshots over, you have to make sure that the standby is being restored correctly. You have to make sure that you can check certain things within the standby to make sure it is in a functional state. Within Portal, we have an index, and the index is used for searches. When you bring up My Content, that's a search request. Obviously, if you search within the Home app, that's a search request. So everything is using the index to make sure it's bringing back the information that you need. A step that you can go through is once the restore is done on standby, go through a certain number of checks to make sure that it is in a functional state. Checking that the index is in sync for the portals, and this could be on both of the portal machines. You can validate all the federated servers, make sure that they validate that they're all accessible. You can validate all the data stores within server admin. You can also, if your organization has specific services or applications that are particularly important for your organization, you can check those, make sure that they're accessible, make sure that they're returning data, let's say a simple query request. So yeah, I mean, you want to make sure, as Cherry mentioned with health checks, you want to make sure that you're detecting component level failures as well. The load balancer can be configured for health checking. The web adapter is automatically configured to send requests to healthy machines, but if administrators don't get notified of that failure, then you could run into a situation where you have a single point of failure. So you had HA portal, your standby goes down, or your primary goes down, and you're left with that single portal. If you're not notified that you only have a single portal running, you do have a single point of failure, even though you were HA. So detecting failures is really important in any of these types of environments. So failing over data centers can be expensive. Making sure that you need to make sure that your standby is in a state that it can be promoted to primary. This is by doing some of the things like checking the index, validating federated servers and that sort of thing. And it's also, as I mentioned before, you could have your primary data center on the East Coast. That's where all your users are. Well, then how do you kind of flip back over? So that's another thing that you have to keep in mind is that, when you do have to fail over data centers, there is some data synchronization that you have to deal with. And it really just kind of goes the other way, right? You take a backup from standby, you restore it to primary, and then you flip over back to primary. So here's some of the takeaway points that I want to leave with specific to geographic redundancy. So it's important to understand the requirements of geographic redundancy as your disaster recovery option. Being familiar with how to replicate file servers in the event that you have any file-based data, or any databases or geodatabases that have to be replicated between primary and standby. You should be familiar with a WebGIS and ArcGIS Enterprise and how all those pieces tie together. Be familiar with the internal URLs that Cherry was mentioning, the private portal URL and the admin URL. Familiar with monitoring tools, whether that's using ArcGIS Monitor, whether it's using load balancing and health checking, along with something to monitor or to notify you of any failures is going to be really important. And again, as Cherry mentioned, drills are crucial. I was just talking to someone today that mentioned, well, every year for a week we flip over to standby. I mean, that's a great way to go about making sure that your standby environment is up and running, that you do know what is involved in flipping over to standby. You don't want to have to fail over to standby and you've never done it, and you don't know the exact steps or any of the nuances involved with flipping over to your standby environment. In regards to the disaster recovery tool, it's important that you're familiar with how much content you have in your enterprise, how long it takes to create a backup, how long it takes to apply a backup, because that's all going to be involved in establishing the correct schedule for taking and applying backups. And something to again keep in mind is DR is complex. So if keep in mind that maybe HA in a single environment is going to be good for you. But obviously, hopefully we've given you some tips and some information that if you do plan to go through the disaster recovery with geographic redundancy route, that you have everything you need to be successful. And we do want to hear about that. We do want to hear of your success stories with HA and DR. But obviously we want to hear about any failures or any issues that you have, any concerns that you have with these. Enterprise readiness is and continues to be a big focus of ours. We want to make sure that the software works in these larger enterprise environments. So we want to hear about your feedback, whether it's positive or negative. So with that, please take our survey. We want to know, how we did and if there's anything we can improve upon. And with that, we can open it up to some questions. Yes?
So we have that piece highly available? I didn't catch that when we were talking about it. Do I need a second set of web adapters, the admin URL, or?
It's a good question. So the question is, how do you make the admin URLs highly available within an enterprise? And are you talking specifically about, let's say, the admin URL used to federate, or is it the? Okay. So that should be through a load balancer. It should be through highly available load balancer that's able to send the traffic to each of the machines. It should bypass any Windows authentication that you have, because the internal communication isn't going to handle that well. So going from, let's say the load balancer, you tell it to listen on 6443. The server pool, the backend pool is, you've got server 1 and server 2. It's to send the traffic directly to the servers over 6443. And the load balancer URL, that's going to be the URL that you're going to use within your federation. You have the services URL and admin URL. The services URL is obviously the web context URL, but the admin URL is that, the internal URL that bypasses any authentication and can communicate with both of the server machines. If you have a deployment that you want to move to BHA, you can always update that admin URL. We have documentation and steps that, let's say you did federate with pointing to S1 or server 1, or you did federate pointing to server 2. We have steps within our documentation to update the admin URL. Because obviously, if you're familiar with Filippidi and his notes on do not unfederate, yes, I'll say that again, don't unfederate. You can update those URLs within the enterprise.
I have two questions regarding highly available portal configuration. The first step, in my experience with 10.4, 10.5, and 6, whenever there is some plant maintenance in the data center, we have to respect what order. So you first shut down the secondary, then primary, then secondary. It seems that in 10.7 we don't have this issue, because you are saying that we can upgrade in any order. So just want to confirm with you. The first question.
Yeah.
The second question is regarding private portal URL and web context URL. Because for example, when we have no security constraint and we are in an organization and we are not using WebGIS authentication is portal tier, can we use the same URL for web context and portal URL?
Sure. Yeah, so I think first, to answer the first question, I can describe what happens during failover. Situation is let's say you shut down standby, and then you shut down primary. The conception is that, well, you start standby, and it should assume the role of primary because the primary is not available. Well, that's not exactly how it works. And the reason it doesn't work like that is, let's say you have primary and standby. You shut down standby, people can still use primary, right? People can still create content. You can create users, groups, and that sort of thing. So then primary goes down, and standby comes up. Well, the database standby can't get the latest database from primary. It can't get the latest users that have been added or the groups, because the primary isn't up. So what happens, given that, I'll describe kind of the proper fail-back approach. So you have primary and standby. Standby goes down, you create some content, create some users, standby comes back up. At that point, if you guys are familiar with Portal HA, within the ArcGIS portal folder, you'll see a DB with a timestamp. And what's happening is that we're creating a backup of the database. It's just a snapshot of the database, and we're getting the full database from primary to move over to standby, so that standby has all that it needs during its downtime. And so really the whole process is just to minimize any data loss that could happen. We don't want to just immediately promote standby because it may not have all the data from primary. So that's the reason why order is very important. And if you're applying patches, or you're going through some planned maintenance, a safe approach is to just do everything on standby first, or do everything on one machine first. Either allow it to fail over, or allow it to kind of come back and rejoin as standby. But yeah, order, and especially when starting up, is going to be important for Portal HA.
For the second question, whether you can use the same URL if you don't care about web tier authentication, yeah, we actually, for some of our automation or deployment in the cloud, we have some samples even that way. They use the public URL for both the private URL as well. Just keep in mind that that means that all your communication is through this public URL. So just keep in mind that a lot of organizations don't like that. They want the private communication to be private. But if that's not a concern to you, that would work. Yeah.
And along the same notes, we do have deployment scenarios within our documentation. And it describes doing something like that. You want a load balancer, you just want to have one load balancer. You can use it for the web context URL for both portal and server. You can use it for the admin URL as well as the private portal URL. And then we go through other different scenarios, like you want IWA, you want SAML, or you want one load balancer in the DMZ, and you got another one internally. So we go through a couple of those different scenarios within the documentation. And you can search deployment scenarios for ArcGIS Enterprise to find that.
We'll take the next one, and then if you have more questions, we run out of time to come to talk to us and expo out there. Go ahead.
So last question is regarding URLs. So let's say we have host 1, host 2, to the high level, and we also have the package URL. When we set up the federation for the individual servers, do we provide them the package URL, or do we provide host 1, host 2?
So you always, whenever you federate, you want to make sure that you're not ever pointing to a specific machine, because that machine can go down, and then your federation is going to be broken. So within your federation, the services URL and admin URL, you want to go through a load balancer. Was that your question? Okay. The other thing that I think we have to update in the documentation, when you register the DataStore, the DataStore you provide, the example is server machine and over 6443, and that can really be any URL that can connect to the admin endpoint of server. It doesn't have to be through a load balancer. It could be through M1 or server 1 or server 2. Behind the scenes, DataStore has logic to figure out what machines participate in the server site, and it's able to update its machine list and update its connection. Allowed connections file to make sure that it is aware of all the machines. So that's something we got feedback for, and we plan to update in the documentation about recommendations of what URL to use. But you can use any URL that can reach the admin API.
And the opposite way, if you register DataStore with your server, when the primary is done, server understands, your standby is the primary now. That switch is also taken care of, so you don't have to worry about which URL to give, which machine name to give. I think that is the end of our presentation, and thank you very much.
Yep.